term metal usually brings to mind materials like iron, steel, copper, lead, gold, and aluminum. Today we will look at the alkali metals, lithium, sodium, and potassium. The alkaline earth metals, magnesium and calcium, and a group 13 metal, aluminum. Specifically, we will explore the relative reactivity of each of these metals with water, and we'll look for patterns. This is lithium, which we're going to react with water. As you can see, a gas is produced, since one reactant is water. Two likely possibilities for the identity of the gas are hydrogen and oxygen. We can use a match to see if the gas is one of these two. Since the gas is flammable, it is most likely hydrogen. The only reactants were lithium and water. Since hydrogen gas was produced, it had to have come from the water. I will use phenolphthalein indicator solution to identify one of the other products. The pink coloration tells us that the solution is basic. What ion is present in basic solutions? The hydroxide ion. We added lithium to water and produced hydrogen gas and hydroxide ions. But we still need to account for the lithium. Even though we can no longer see any of the solid metallic lithium, it has to be present in some form. What is that form? The lithium exists as lithium ions. Therefore, in the reaction between lithium and water, we've produced hydrogen gas and lithium hydroxide. Is this equation balanced? No. We need a coefficient of 2 in front of every species, except for the hydrogen gas. This is sodium. I'm going to place it in water. Observe whether a reaction occurs or not, and if one does, note the relative rate as compared to the reaction of lithium in water. Once again, a flammable gas was produced that is probably hydrogen. The reaction generated enough heat to ignite the gas. I'm going to add phenolphthalein indicator to the resulting solution. We can see that hydroxide ions are present. This is potassium, which I'm going to place in water. Again, observe whether a reaction takes place, and if so, note the relative speed of the reaction as compared to those for lithium and sodium. Like the other reactions, hydroxide ions are present. We saw that all three of the alkali metals tested reacted with water to produce hydrogen gas and form a basic solution. As we go down the group of alkali metals from lithium to sodium to potassium, did the relative rate of the reaction increase, decrease, or remain unchanged? What would you predict would happen if rubidium were added to water? Cesium or francium? We will now look at the behavior of magnesium and calcium, two alkaline earth metals, in water. This is magnesium and this is calcium. The magnesium did not react, but the calcium did react, and it appears that the calcium reacted similarly to the alkali metals. We saw that magnesium did not react with water, but calcium did. As we go down the group of alkaline earth metals, what happens to the relative rate of reactivity of the metals with water? What do you predict will happen if strontium or barium is added to water? Is the pattern observed for the alkaline earth metals similar to that observed for the alkali metals? Comparing sodium and magnesium, which was more reactive with water? Comparing potassium and calcium, which of these was more reactive with water? Do you think that aluminum will react with water based on the observations? Let's find out. No, it does not react. Neither the magnesium nor the aluminum reacted with water. We will test both of these with acid to see which, if either, is more reactive. I'm going to add 1 drop of concentrated hydrochloric acid to each dish containing the metals and water. We can see that the magnesium does react and a gas is produced, but the aluminum still does not react. Let's see if the addition of more acid will result in a reaction. With enough acid, aluminum does react. Chemists refer to the trends or patterns in the property of elements in 2 ways: group trends and period trends. Group trends refer to a specific family or group in the periodic table, such as the alkali metals. Period trends refer to a particular row or period of elements, such as the 3rd period, sodium, magnesium, and aluminum. In your own words, what would be the group trend for the alkali metals in regards to their reactivity with water? For the alkaline earth metals? What would be the period trend for sodium, magnesium, and aluminum regarding their reactivity with water? With hydrochloric acid? What about for the 4th period elements, potassium and calcium? Although we did not test gallium, what would you assume about its reactivity with water and with acid as compared to calcium and to aluminum?
Now we're going to repeat the reaction between sodium and water on a much larger scale.
Okay, we're recording.
Okay, here we go.
Careful, that ground is wet.
Yeah. Now I'm gonna pick up with tongs. Okay. Ready?
We're still recording.